Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, this is a random long video format topic. It's not so long, but I will place it under a long video format so I could use my teaching method on how to explain this one. I don't want this one to be placed under the short videos because it seems I don't know how to, what you call this, teachings. So for tonight, I will be discussing the so-called evaluation of definite integrals. This is a random topic. I am done with integral calculus. So I will be placing this one under my mixed topics because under my mixed topics, it's lots of mathematics, electronics, and other things. Okay, let's proceed. Long video format, the topic is the so-called evaluation of definite integrals. It's a simple problem, but the important thing here is how do we explain to the viewers. We are given the problem. Evaluate the integral from 0 to pi over 2. The given integral is sine of theta, differential theta equal to. It's a simple problem, but I would like to show how we could evaluate this one. And for those who don't know yet to evaluate integrals, this is for you guys. Okay, let's try to bring out the solution. I will be rewriting the given integral, so this is the integral from 0 to pi over 2, sine of theta, differential theta. There is a straightforward solution of this one because the integral of a sine function, any sine function, will just be simply the cosine of that, but it should be preceded by a negative sign. How do we know if the integral of sine of theta, differential theta, will be negative cosine of theta? Because if we try to differentiate this one, what will come out will be the original problem. So if we try to differentiate the derivative with respect to theta of negative cosine of theta, okay, with respect to theta, this should be equal to negative open quantity. The derivative of cosine is actually negative sine of theta times differential of theta. So a negative, that's algebra, it will now be plus. So this is now plus sine of theta, differential theta. So the integral of sine of theta, differential theta, like what I said, it should be the cosine of that, but it should be preceded by negative sign. And as a check to the validity of our answer, we take the derivative of this negative cosine, and what comes out is sine of theta, differential theta, the given original problem. So regarding the evaluation of this will become negative cosine of theta, open bracket, from 0 to pi over 2. Lower limit, upper limit. We have proven that the integral of sine of theta, differential theta, is negative cosine of theta due to this. So this will be negative cosine of theta, like what I said, the lower limit is 0, the upper limit is 0 to pi over 2. And regarding the so-called evaluation of definite integrals, we will start with the upper limit. Then we subtract the value of the lower limit. Right? So I will be following this. Negative open quantity, cosine. The upper limit will be pi over 2. Minus, open bracket. Again, there is a minus here. Cosine, the lower limit is actually 0, close bracket. Okay? This is actually in terms of regions. Right? So it's a must that we should convert or know the equivalent of regions to degrees. So this will be the so-called translation of the regions to degrees. We know that one complete circle is 2 pi regions, and this will be 360 degrees. Okay? Pi regions, if we divide this by 2, pi regions now, will be 180. Right? Because this cancels. Again, if we divide again pi regions by 2, okay, pi over 2 regions now is 180 over 2, and that will be 90 degrees. The cosine of 90 will be 0. Right? And sine of 90 is 1, but this is cosine. So this is negative open quantity. So it seems this pi over 2 is now 90 degrees. Right? And the cosine of 90 is actually 0. So this is open quantity, 0, close bracket, minus, open bracket, minus. We are subtracting. The operation here is subtraction, but we must have to place the proper sign inside. So this is minus open quantity. 0 radians or 0 degree. This is 0 degree, right? And cosine of 0 is actually 1. So this is times open quantity, 1, close quantity, close bracket. Okay? Actually, this negative thing is, it seems there is a 1 here. Right? So a negative 1 times 0 will be 0 minus open quantity. This is the inside thing is actually a product of a negative 1 and 1. But this is a negative and a negative, so this will now become plus. And negative 1 times 0 is 0. And if we try to remove the bracket here, it will become a plus 1. So the final answer here is plus 1. Okay? That's the solution of this simple definite integral evaluation. That is the integral from 0 to pi over 2 of sine of theta differential theta. And here you should have the knowledge of the so-called study of differential calculus. Because without knowing your knowledge of differential calculus, you cannot integrate. That's why they check to the validity of this negative cosines actually by taking the differential. And when we talk the differential, what comes out is the original problem. Right? So, like what I said, the integral from 0 to pi over 2 of sine of theta, differential theta, is negative cosine of theta with a limit from 0 to pi over 2. And regarding the conversion of the angles, it will be this. Okay? Cosine of pi over 2 will be 0, because pi over 2 is 90 degrees. And cosine of 0 is actually 1, so this will become 1. And a negative 1 times 0 will be 0. And a negative 1 times a negative 1, it will become a plus 1. So the final answer is plus 1. Okay, good evening from Los Angeles, Professor David J. De Los Reyes.